Hello and welcome to Apex Extra Live. Does big data have big potential for you? With Jonathan Thatcher, CSCP. My name is Christopher Jablonski and I'll be your host for today's broadcast. Please note that this presentation is being recorded and will be available at apex.org/extra starting early next week. Before we begin, I'd like to run through a few details. At the end of the presentation, we'll save time for a question and answer session. If you look at the right toolbar on your screen, you'll see a questions box. To ask your question at any time during the presentation, simply type it in the box and click Send. Should you experience any technical difficulties during today's broadcast, please call GoToWebinar Tech Support at 1-805-617-7000. Our speaker today is Jonathan Thatcher, CSCP. Jonathan is Apex Director of Research since December 2008, and he's also the author of the Ask Apex department in Apex Magazine. The Apex Research Department produces research reports and folios on many current topics in supply chain and operations management, including supply chain strategy, risk, S&OP, sustainability, and big data. Coming soon to the Apex Research Department are research and folios on the subjects of project management, chronic supply chain disruption, and remanufacturing. The Apex Research Department would also like to thank everybody who takes some time and responds to and completes their research surveys. And now it's my pleasure to introduce our speaker for today's webinar, Jonathan Thatcher. Jonathan.
Chris, thank you very much. It is an honor for me to be here. And if I slip into my radio voice, then you'll just have to stop me. I have too much fun doing webinars. News, weather, and sports call now. All right, thank you everyone for joining us. Does big data have big potential for you? This is the topic, and I'll be using the word big a fair number of times. This is a big topic and a big amount of slides. And let me go to my next slide. And a quick presentation outline. What I presume for many of us in our industry is we see big data, it is coming, get ready, do something, perhaps due diligence, perhaps implement, but how do we do this? Because big data is such a large topic, and perhaps we have past experience with implementation of large IT systems such as ERP systems. What can we learn from past experience, and what do we need to know about big data? So that's the overall view of the presentation. The presentation is broken up into 5 sections: current status, the hype versus reality, big data early adopters in our industry. Then in the middle of the presentation, we'll look at a scenario, potential pilots, a big data pilot, what that might look like, and then questions to answer from a pilot, and finally next steps, finding talent, and taking your questions. So if that sounds good, then let's go ahead and launch into the presentation. So often with big data presentations, you'll see the big numbers, and I wanted to share some of those with you. At the end of year 2011, estimates show that there were more network devices than people on Earth, and about 90% of the world's data was created in just the last 2 years. Why this is happening, and the big revolution we're seeing right now, is in the past, data used to come from people, and now data comes from both people and devices, and there's more devices than people. And all of us produce a whole lot of data. In fact, 1.8 zettabytes of data were produced in 2011, and by 2015, this will increase to 7.8 zettabytes. Imagine if this were a supply chain. Produce this amount of growth of data in a production mode. A zettabyte, by the way, is a 1 with 21 zeros. So this is a large number. Now, given this big data, this tidal wave of data that is encircling us, what do things look like for the practitioner? And we ran a survey last year in 2012, and we asked, and just to kick off this presentation, I wanted to show what we see, what challenges us in terms of the data tidal wave within supply chain and operations management. And here are a number of bullets, real summary items. Useful data, getting a hold of useful data rather than sorting through trivial data was a tough challenge. Another one was getting reliable, trustworthy data all the time. We have data all the time. Some of it's reliable and trustworthy. Is it that way all the time? How do we know? Timely data, live or near live data, and not waiting for slow batch reports was a common one, concern. Others were data shared easily in workflows with others, meaning, well, we have the data. Is it data that speaks for itself? Is it data that has context so that other people, other groups and departments can make sense of it, and not just a specialist make sense of the data? a data scope. In other words, we see data that begins from our supplier and ends with our customer's customer. We don't have enough long data, meaning data that has a long historic past, which makes it especially good for forecasting. So if we have data going back many years, we can see how the data performed in an up economy, down economy, when the company was growing, et cetera. And then the final two, data free from inefficiency and complexity. It's still common for us to have to go to multiple systems, platforms, devices, spreadsheets, files, you name it, to get a coherent mix of data that we need. And then the last one, data integrated with preferred platforms, reports, devices, dashboards, and I could mention processes and so on. Oftentimes the data we want to use remains outside of all those preferred processes, platforms, and systems and reports, and we have to put it there. So that is an imperfect world that we face right now. Now, what does big data promise? It's going to fix all that, right? Perhaps you've seen the hype. Big data is hot, jump in quickly, beat the competition, start buying some hardware and software. If you've seen that kind of beat, if you will, if you've seen the hype out there, you're definitely not alone. But what I would recommend is don't jump into that, at least not yet, because there's some prep work that you want to do in advance, because big data is so big a topic. We want to begin with a bit of investigation and due diligence, and it really begin with some strategy in mind. Investigate, number one, the people, processes, and data that are going on now in your company and that you reasonably anticipate in the future. This would be the number one step before implementing anything, is to get the big picture around people, processes, and data. And you could say, well, that's a pretty big topic. What do you mean? Specifically, the people, process, and data, which are aligned to your business unit or to your company, and its strategy, its budget, its needs, its plans, its goals, its competitive pressures. And in this regard, you'd have to act like a chief executive officer of some kind. Of course, not in a perfect sense, but start gathering data at that level. And then from that perspective, produce strategies, roadmaps, plans, goals, tactics over a life cycle of use of data, of technologies, of expectations, of processes, of goals that are currently and expected to be current in a few years within your organization. Now you can say, what does all that have to do with big data? Nothing quite yet, but it does set the table. It does create a strategic view, and it does allow us to later connect that strategy to tactics and use of data, and then plans around implementing data that will be important, rather than just simply jumping in because the hype says to jump in. So where and what is our most useful data? If you're a supply chain or operations management professional, or how do we change our processes to make use of this data, or how do we capture more comprehensive data where it is needed? These are great questions, and hopefully we'll explore them with some detail and have some useful insight at the end of this presentation. So I'm setting the expectation there. As a starting point, the role of big data, what is it? What it is at a high level is sets of data today, your databases, you name it, production, finance, membership, if you're an associate like Apex, or customers, there'll be lots of databases, there's lots of large blocks of data, and they're increasingly too large for any one human being to understand all of them, let alone capture, store, process, search, analyze, report within all of them and create a coherent picture. And what that problem boils down to is what some call the 5 V's of data. There's data volume, there's too much data, or data velocity. It comes at us too quickly, and there's too many different versions, or it's updated too often and we don't know why the update occurred or what was different from the last version. Data variety is too many different kinds of data. Unstructured data, trivial data. Let me just pause here. The term unstructured and structured data, you might have heard about in looking at databases or big data or whatnot. Structured data essentially is data that can easily fit within a traditional database field, a zip code, a name, an address. Unstructured data is data that doesn't quite so easily fit a field. Unstructured data could be a photograph, a sound file. It could be a snippet of text from an email, something you copy and pasted from one document into another. In other words, it's not clear exactly what that data is. That's unstructured data. And unstructured data is rapidly growing in our time. And it is a problem because traditional tools don't easily work with it. Same with trivial data. It used to be when humans produced data and put it in databases, it was clear why the data was needed. There was a data field, and a data process crunched it. Now, it's not so clear why the data was useful in the first place, or what produced it, or who needs it. So that's the data variety problem. Data veracity is the reliability of the data. Is the data reliable? Is it valid? Is it true today? Will it be true tomorrow? Is it equally true for me as it was for another department that produced it? Is it an outlier, an unusual, or is it right in the middle of expectations? And then finally, data vision. What is our strategy that makes use of all this data? How do we keep up with the rest of the V's and find value? If data is an asset, like cash is to a company, how do we best make use of it? How do we deploy it? So those are the 5 V's, and I'm sure there's other V's, but that's probably enough for our presentation at this point. So given all that, what does big data promise today? Well, if you look at commonly what's offered, and I'm just speaking in general terms, generally big data says it will gather and process and report every bit of data from all sources. How does it do this? It builds on web search engine technology. Back in the mid-1990s, when the internet started becoming vastly mainstream and everyone started accessing the internet, it became clear that traditional databases could not keep up. Say if you're a Google and you're indexing every other search or every other website because you want a search engine, or if you're Amazon and you want to sell every type of book and then every other type of music and so on. And this created the need to start indexing, capturing, processing, and reporting large amounts of data produced by other devices. The technologies that do this, Hadoop, NoSQL, a variety of analytical technologies and calculated processes and so on, I don't want to get into here, but they are available, and this is really the core of big data for now. So if you're able to process and report and so on and index, what does that do? Well, it does several things. One is you can rapidly correlate and report insight between 2 bits of data. And you can see this in a search engine, for example. If I were to search on the word petroleum, for example, in a search engine, it would show me all sorts of things about oil, where to buy it, where it comes from, perhaps the chemistry involved, its uses. So it connects that concept to lots of other things, and it creates a correlation effect. It will correlate one subject to another, and that can be a source of insight. Another one is it can provide the full context of data. From a vast forest you see down to an individual tree. A data point's origin, its dependencies, what it's connected to, its relevance, who uses it, when it was last accessed, and so on. And then finally, big data can provide objective data. It replaces guesswork, opinion, confusion, because, say, in terms of forecasting or decision-making or analysis, when the human mind starts to look at lots of variables and has to make a decision, big data can say, by the way, if you want to know this bit of data for this decision point, I can tell you all about it. Or it can also notice what is unnoticed. Big data is great at looking at hidden connections, at looking at data that no one has really seen before, because no human has just ever had the time to sort through so much data. And from there, you can create better anticipation and customization. Finally, there's insight without the complexities. Big data itself will handle formats, different formats and systems and file types, and produce data that is useful in all these terms. So that's the promise. Now, that sounds pretty good, but we as supply chain practitioners and operations management professionals and so on, that's not enough for us, because we have what's called the in problem, with so many systems and processes and improvements already going on without big data. And then to overlay big data on what we're currently doing today, what do we in? How do we incorporate? How do we install? How do we initiate? How do we integrate? How do we include? And there's many other in words, I'm sure, in the English language you could connect with big data. A comment you might hear is big data is already a moving target of promises and technologies, and our operations is already a moving target. So I'm aiming one moving target and another moving target, and you're exactly right. So what can we learn from all that? Well, one way is to say, well, what if we were to copy the people that have already put big data into use? This would be the early adopters. In general, manufacturing, supply chain operations management are not among the early adopters. The early adopters of big data were e-commerce, finance, and telecom. the reason why e-commerce was a natural, because you had to have a way of tracking so much different kinds of data across so many different customers so quickly 24/7. Finance and telecom were early adopters, partly because of regulatory issues and partly because of having deep systems that had to track down to the smallest bit and byte of data, of a minute of telecom traffic or a dollar or a cent of value. And they had a head start, so to speak, in determining how to implement even bigger database processes. For us, we're at more of a starting point. We do have plenty of data and databases, but rapid innovation and change, lack of talent, lack of customer procedures and practices to make use of big data, and a sometimes blurry line between business analytics and business intelligence. Business analytics is the practice of iteratively going through data, usually in a statistical process, and then business intelligence being an umbrella term, a broad category of technologies. And what do we define as all data? So as industry professionals, we need to express what we want, what we need to see from the world of IT and databases and so on, what serves us. And that's partly what we're doing here in this presentation. Asking questions or APICS research producing surveys, we find out what we need as professionals, what we want as an industry, and then APICS helps express that. So we get from the big data world what we want and not what someone thinks we want. Okay, here's a question I sometimes get. If big data is so wonderful, if there's early adopters, if other people are doing this, how come I don't have big data yet? How come other people haven't worked on these problems? How come it's up to me, so to speak? And these are great questions for a researcher. And what I've run across is what you see on this slide are just some examples of the questions that we haven't been able to answer yet, or in general, as an industry, as practitioners, or at least not yet. Some examples. Accessing archive data in big data projects. What information do we need live or near live? What should be archived? If we have so many processes and sensors and partners and customers, we'll keep everything live or keep everything near live. But it finally gets to the point of, well, what don't we need anymore and what should we consider? Even if we have a big data system that can look at every last detail, we still want to have some time-bound, well, here's the most current, or here's the most valuable bit of data, and here's old, considered old data. Finally, visualization and comprehension of complex data. It's difficult to do with traditional tools. It's tough to create a spreadsheet, a slideshow, a graph that shows 20 different big complex variables and says, and here's the decision we need to make. Another one is millions and millions of data silos exist between supply chain partners and customers and suppliers, not to mention interoperability processes. What are the business relationships that help overcome all that? Do our suppliers, our partners, our customers, do they trust us to share with us their data, to open up their silos, their systems, and let us look? And do we trust them? Finally, two others, overlapping IT strategies. The IT world is already awash with new technology, cloud computing, data warehousing, security, business intelligence, and we want to add big data on all of that and make sure big data is all integrated. That's a big topic. And then finally, there's the good old, let someone else do it first. Let's see what the risk and expense and lack of standards are like. Why not be a late adopter? Let's see if it's worth it in the first place. So that's why we don't have it already. Just examples of why. All right, so that helps set the table. Let's say that we did want to implement big data, and I'll just pick a scenario. Let's say one of the driving forces was senior management says, you know, we need to find and keep more new customers. We need to create more demand. We're doing all we can. We're just not doing that well enough, but we're sitting on a whole lot of data, and we think big data is the way to go get that done to find and keep more new customers. So you just go have at it, make it happen. If you were to say, great, let's go do it, and you were to hold a kickoff meeting, you might hear some of the following pushbacks or a bit of resistance on this. See if this is common in your organization. Number one is, well, we treat all of our customers the same great way. Everyone gets great service from us. We don't think there's a problem with keeping our new customer service. They're all getting great service. And what do you mean, how can we use data any more than we have? We know all about it. So big data would have to get to the point of customized service, joint priorities with customers, realistic expectations, what works in the real world. Another one might be, well, We were surprised by customers' sudden negative turn. That's true. Some customers are leaving us, but we try hard to recover, and we can't win them all, after all. But and when we do try, nothing seems to help. Customers leave, they leave. That's it. So big data then would have to help us at reacting, learning after the fact, even before the fact, building relationships, discovering what difficulties a customer might have in advance, and enabling us to respond to it. Another one would be, well, I'm busy. Account managers handle the customer. They'll tell me if there's a problem in my area. And this is a common problem that big data claims to solve. Well, it'll break down silos. It'll find the missing opportunities. It will resolve the lack of the big picture. So these are some realistic human responses to, well, let's just implement big data. And these are the types of responses you'd have to anticipate in implementing big data. You might remember some roughly similar concepts when ERP systems said, by the way, this is the way to go. It's going to solve it all. And an ERP system is implemented, and people say, you know, I'm just not comfortable with it. I'm going to stick with my same old familiar processes because that's what I trust. So it gets down to a question. Is a big data implementation, even a big data pilot, is it realistic for your company right now or for you to consider? To answer that, let me throw out a few ideas. Number one, does big data present an opportunity that justifies the risk of people, budget, and time? Of all the other things you could be doing with people, budget, and time, is big data the way to go right now? And to answer that one is looking at the return big data would have, expectations, risk management, costs, organization, potential to grow. There's lots of potential, but there's some risk as well. Is the risk and reward balance there? Number two is there a clear need? Is the competition implementing big data? Are new organization strategies and leadership demanding it? Is the organization outgrowing systems and analytics capabilities so quickly that this is the next step? Another one would be the pilot would be realistic if it would be managed well, but it wouldn't be realistic if we couldn't manage it well. So would a pilot have senior management sponsorship? Would there be an intense focused R&D built around it? Or would it be a closed pilot in a skunk works and just one team tries it privately? Would it be large scale, small scale, ad hoc? And then finally, are all the players, senior management, IT, finance, stakeholders, and partners, are they all on board? Or is the hype just getting to an individual, a senior manager somewhere, but that person is not really closing the loop elsewhere in the organization? If you're saying, well, you know, I can answer all these questions and we have good answers to them, then a big data pilot is maybe a good idea to go forward with. And I just want to say, is it possible to pilot big data without big data? In other words, we're ready for big data, but we don't have the budget. Or we're ready for big data, but we just don't know how to implement it because it's such a vast process. Is there any way to start small? Is there any way to explore big data and not have to jump in with both feet, so to speak? And there is a little bit of a way, and I'll propose it here in these slides. It's possible to do a small manual approach, not actually using big data, but to be inspired by big data, if you will. Make use of some business analytics, business intelligence. Imagine if you did have every last bit of data targeted on a particular problem or a particular issue to solve in a reasonably sized group, and see what you find. Now, what this kind of pilot would do would not be big data per se, but it would test out how big data might roll out or what issues you might encounter in implementing big data or in building up towards a big data implementation. Gather evidence, develop ideas for actual big data implementation, and explore the technical and non-technical issues that you'd run into. That's what a pilot without big data systems could do and look like. It'd be a stepping stone. An example would be a customer-focused pilot. This is a classic one. Lots of companies have all sorts of data on their customers, but they don't easily track each customer interaction. In other words, if a customer sends an email requesting customer support, a big data system could notice that and say, by the way, this changes the probability of the customer doing business with us within the next 90 days because the customer used a word related with a dissatisfying situation that, say, 60% of other customers who use this word also relate to. That would be in the gathering and noticing. In the processing of data, a customer pilot might find through analysis, correlation, insight, here's what we could be selling more to the customer, or here's what we shouldn't be pitching to the customer because they don't care about it and we're using up that customer's attention bandwidth. Reports to act on findings, forming conclusions and next steps and decisions about what to do with customers, and then repeating the cycle with an ever wider scope of customers or opportunities so that insight builds on insight, or decision builds on decision, so decision performance improves. This is what a limited pilot might look like. To do that, what I'd propose here, one example would be a customer scoring pilot. And I'll lay out a few steps here. What do I mean by customer scoring? Well, everyone's heard of the Pareto principle, 80-20. Say roughly 20% of your products account for 80% of sales. And then the other remaining products, they also account for sales, but just not so much. And so with the Pareto principle, you really pay attention to that 20%. You can do roughly the same thing with customers, and some people do. What big data allows you to do is really measure and score every customer using every bit of data. For example, form a pilot team, stakeholders from both supply and demand, say from a sales and operations planning group, define a set of customers, data mine those customers to see who are the most valuable current customers and assign a score to them. The customers who buy the most, who have the potential to purchase the most, customers that buy the least, customers that engage most frequently or least frequently, customers that go through the sales cycle fastest, customers who we really have order winners with, customers who are hard to work with, etc. And then do a first pass through that, and then start looking for outliers. You might find a few customers who get more attention than they should, or you might find there's valuable customers that aren't getting as much attention as they should. Ask the team that you've created, not just the customer's account manager, but the team, why is that the case? Why are we seeing what we're seeing? What makes a Pareto principle customer? What makes the 20% of customers responsible for 80% of sales? If that's the case, why is that so? And why aren't the other customers like that? Ask the 5 whys and start building up cause and effect. Cause and effect data, we'll see, pays off later. Another thing to do while you're doing this is to start looking at customer sentiment, customer events, or gathering clues, a bit like a detective. Say, with the same collection of scored customers, now you have rough scores for them, find clues that indicate customer sentiment in every transaction or every interaction, a customer visit, a call, an email, an order, a contract change, an order change, what have you. Define those as events and see what you can learn from them. Are they positive? Are they negative? Are they neutral? Why did they occur? Or do we know why they occurred? And see if that new knowledge would alter your communication back to the customer, say in terms of offers, negotiation, or information sharing. Each clue really is a data point. And most clues won't have very much weight. They won't be very important in and of themselves. But what happens is clues kind of form their own network. No one is important, but when you look at, say, 50 clues all put together, it's like putting pieces of a puzzle together, and you start seeing the forest rather than just a customer-specific request or complaint. You see a little wider picture, a little more context, a little more connection between different ideas. In other words, the promise of big data. Now, you're doing this manually, of course, but you'd be seeing what a big data system would promise to do, and you could see, well, would it really deliver? Part of this you might call as customer sensing or customer evaluation and so on. This has long been in existence, what I'm talking about here. But treating it as a big data question is somewhat fairly new. So as you look for sentiment and clues, do valued customers from step 1, do they have the best sentiment? Are they providing the right clues? And then why or why not ask the 5 whys. Up next would be, do valued customers, does their data align? Are the most valued customers receiving the attention they need? Are communications or offers or engagements effective? Where are data blind spots? In other words, what didn't we realize that we're realizing now? And what problems that are now obvious, why weren't they obvious before? Or what were the bits of data that made them obvious? In other words, since we know a bit of data, we have a clue, we know this transaction occurred, now that we know, why didn't we know it before? Or if we see that come up again in another customer, is that transferable data? So with this data gathering, is it possible to better predict customer sentiment in advance or better predict customer need in advance? And then finally, do the right stakeholders, the right people on the pilot team, do they have the right picture? Are they able to act on it? Can they make decisions? Are they sharing this data? And so on. By now, I think you can see that we're testing a bit what big data systems would promise. If you installed a bunch of hardware and software and you let loose and it went to town, would you actually make use of it? Would you be finding ways to make better decisions on it or to act on it? So we can see for better customer satisfaction, providing data to more people through more potential customer needs requests, or better tying our actions to those, the customer needs and requests. Formally providing responsibility to act quickly to customer requests. These are human interaction terms driven by big data. So other examples of that would be, say, improving forecasting based on clues and sentiment. Forecasting, I know, was hard enough, but if you could add in sentiment and clues in customer transactions and past history, perhaps you'd see a way to strengthen a forecast or improve it. Or you can look at competitive strengths and weaknesses from the perspective of your customers. If they could buy, say, from 3 other companies or 3 other suppliers, what would those other companies look like? How would your customer likely respond to their offers? Do their offers increase the customer sentiment? Do they better respond to expectations and needs? And then finally, what would a big data system look like if we wanted to capture all of our data? Here we're talking about a pilot of just some customers, but now think about suppliers, partners, and stakeholders, an end-to-end supply chain. You can see the potential. It's a big, enormous potential, but quite a complex one. And it would also leave us with a whole lot to act on. And that gets back to, well, do we have the capability to really act on all this data? And that's part of what you need to think about in terms of big data. In fact, on this next slide, I think an IBM leader for advanced analytics North America put it best, as he said, essentially, data alone is not enough. First, decide what the problem is you want to solve. Data by itself alone is not especially useful. You have to put it to work in terms of context and illustrate the business situation it's working on. What value do you hope to glean from the data? And then only then put together a viable plan. So how does all that translate into actual improvement? And does that create a vision and a context for big data? Or how does that exist? Good questions. Well, let's see if we can answer. Number one, back to the early, middle, late adopter. If this is something you're saying, yeah, this is something I can get into, this is something that my company needs, think about, well, is my company really early, middle, or late adopter? It's still fairly early in the big data journey for much of our industry. If you want to jump in right away, then you'd have to run through some of these rocks or rapids, if this were a river analogy, so to speak. Unsettled standards and methods. Different vendors have competing visions. They have different offerings. They have different platforms. And it's not so easy to switch from one to another once you make an investment in one. And that's something you want to know up front. Well, do I have the bandwidth to really do due diligence just on the practicalities of their standards and methods? You could say, well, we were happy with our ERP system. I'll just go with the same vendor and integrate it all. That may be a good solution. Or it might be, well, maybe I'm not so satisfied with it, and maybe here's a way to see if we can get better value. However, does that create now a whole new data management problem? We have an ERP system from one vendor and big data from another. Big questions. Another one would be talent, customization, integration. This is all expensive. An off-the-shelf system probably is not a perfect fit. It might be an okay fit, like an off-the-shelf suit. But if you have plans that are really unusual, or it really has to work in a particular way, or we want total flexibility because one group has to use the data this way and another that way, then you're looking at some expense in customization and integration. There's also risk. The proven capability in web and e-commerce and retail is there, the really early adopters by industry. But it's a little less so in supply chains and operations management. There's fewer people to rely on. Now, of course, the vendors would say, well, we can demonstrate that we do have proven capability. But we don't have past history of years and years going back from purely an industry perspective because we're still in an early stage. And then finally, optimal leverage of existing information technologies and platforms is not yet clear. You have, no doubt, your organizations have huge investments in servers and IT and networks and so on. How do we make best use of those? Do you go to cloud systems? Do you put in databases and servers that handle just big data that distribute the data back out to other parts of your IT system? that type of design and questioning would need to get worked out. If you're saying, well, you know, if all that sounds kind of difficult, or I'm not sure we could face that all right up front, then perhaps, I'm not saying you are, but perhaps you're a more middle adopter or a late adopter. But if you're saying, look, none of those things are all that challenging, I'm going to jump right in, and it sounds like you're an early adopter. Okay, now the question is, well, am I really an early middle or a late adopter? Now, this is where you can look at you yourself as an individual, and you can say, well, look, in terms of big data, vision, standards, methods, are they settled enough for me and my role to act? In other words, given my responsibilities, what the company gives me a paycheck for, I'm pretty comfortable with this. Or in terms of talent and customization, integration, I'm willing to work through these issues. I've done this before, say, with other IT systems or other challenges. Or in terms of risk, supply chains and operations management. I've worked through big implementations in the past. I know how that works. Or finally, I've worked with vendors in the past. I know how to look at their roadmaps and see from that a project, and then see from that implementation, and see from that success. You might indeed be an early adopter. If you're saying, look, I've lived that, I deal with that all day long, and I'm a good fit for that. If you're saying, I can do that, but it would take me a bit of time, then perhaps you're not so much an early adopter, maybe somewhere in the middle. All right, so this all gets back to, okay, where is big data really in the hype cycle? And this is where you look at research from a variety of companies. Gartner, for example, they'll say big data has been in the peak of inflated expectations. It's big, it's hot, it grabs attention, people read about it, and it's just about to fall into what's called the trough of disillusionment. In other words, the hype can't sustain itself anymore, and we get tired of it, and big data really isn't meeting expectations, and we'll go on to something else that's new and hot. The trough of disillusionment doesn't mean it goes away. It just means it gets less hype attention. Now, what happens with other hype technologies is if it moves through a trough, it survives, but then it comes back out of that trough as a more mainstream technology, and it becomes more settled and grounded in a firmer foundation rather than just hype. And if you believe some of the third-party research, some of the secondary research from my perspective, some people are saying that that's about where it is. Other people are saying no, it's being implemented right along. There's a firm foundation. Hype doesn't explain what's really happening, what companies are really doing with big data. And others will say big data is a bit too early to use. It's really more about business intelligence and business analytics, and we're not quite to the big data world yet. So big data is still hype, even though we're heading toward it. Or it's, for now, it's a fad. Tomorrow it won't be a fad, but et cetera. So you can see where people in general call it. All right, big data adoption questions. Really to ask the questions. If you're to say, look, I sat through a web conference today, and there was, I got a little bit of useful data out of this. Hopefully, I'm crossing my fingers. And here's what I want to find out from the team. Here are some questions to ask. Is there really growing interest and consensus across different groups, different departments, different teams about the potential of big data? In other words, are people talking about it because it's hype, or do they see a need? Do they want it? Does business unit strategy, goals, management, culture, history, do they all tend to align towards an early or a middle or a late adoption standard? Companies have cultures and practices, and oftentimes we like to jump in early. That's just the way we are. Or, no, we'd rather wait for other people to do it, wait for the price to go down. We're more risk adverse. Or we're somewhere in the middle. A few other questions to ask. Are there pressing needs served by big data right now? In other words, our competition is really using big data, and they're getting great insight, and they're really clobbering us in the marketplace. Or do we want to implement processes and practices that would really greatly improve by big data? Or is data gathering and sharing a problem right now? Are there silos? If there's a lot of silos and a lot of different databases, and if data gathering and sharing is a problem, then hardware and software alone won't solve that. That'll take some human management and process management and senior management attention to start addressing that. The hardware and software alone won't break through those silos. Then finally, are data analytics and business intelligence practices in place now? Predictive analytics, data mining. Say, for example, if you're practicing lean, and you're going down the lean journey, are you making best use of all the statistics that you have there to demonstrate, well, we're leaner, or we could be doing more, or here's what we'd prioritize based on hard evidence, statistical evidence. Or if you're good at doing that, or are you not so good at doing that? And these are some of the high-level questions to ask, say, to a wider team. So some takeaways. Some next steps here at this point would be consider some internal pilots, or if not pilots, then studies. If we were to try out something inspired by big data, what would it be? Would we want to work on customer scoring customers like I did in these example slides? Or would it be something else? Would it be total quality management? Would it be forecasting or better management of inventory? There's all sorts of topics that big data could work on and smaller pilots could work on. Then work on developing business intelligence and analytics. Then develop and implement a big data roadmap based on what you're finding. And then questions along the way, how can internal processes become more objective, more data-driven? How can supply chain business relationships improve partner data sharing? In other words, do we have the business relationships with our critical supply chain partners right now? Would they share with us more data? Could we get from them the data we would need to feed a big data system? And would we also share with them? And then how would we upgrade our existing ERP systems, our database systems? Would we adopt a brand new additional database, a big data platform? Or would we build in increments, say build up business intelligence and then keep building towards an eventual big data solution? And then do we have data analytics skill in-house? Or would we outsource this? Or is this just too private to outsource? Would we want to have consultants or a data scientist come in and set the stage first of all and then work from there? So that brings up the question, well, where do you find the people? There's plenty of vendors, there's plenty of events and consultants and books and news, and that's not hard to find. But what might be a little harder to find, particularly if you're a medium to large organization, would be a data scientist. What a data scientist does is model and work with programming languages and knows the fundamentals of data, all data, from a strategic view, from a tactical view, from a process view, and all the environments around data. And the data scientist sees that whole big picture and can optimize the flow of data, capture of data, process of data, and set up models and structures and roadmaps that really well apply. A next step down might be a business solution architect. That's someone who knows your data and knows how to make it useful. In other words, he or she would tie data to systems, to processes, to people, to organizations, to departments. And that architect then would work hand in hand with IT and yourself and so on to start to refine and optimize. Now, in the professionals that you'll tend to use for big data, no matter what they call themselves, what you want to see in them are some commonalities, or usually you do. Logical thinking, talented working with both structured and unstructured data, computational skills, big picture, good at strategy, forming insight, forming conclusions, modeling, programming, understanding business deliverables, communication, plus, of course, experience. So these would be some of the attributes you'd want to see in talent you'd hire for big data. For education and certification, if you're interested in this, or if you're hiring people, some of the credentials that they might have mentioned, many of them are interesting, would come from the vendors themselves. There's the EMC Data Scientist Associate, Cloudera Certified Developer. HP has the Big Data Solutions Certification Program, or Databear's Big Data Analytics certifications for analysts and developers. SAS, of course, has a variety of certifications, as does Oracle. And so these are the ones you might see if you speak to vendors, and the vendor says, well, here's how I can prove I'm sending you great people because they've gone through certain programs. From the academic world, you'll see people from science and business intelligence, business analytics. These are forming or becoming more and more common, and you might see a mix of both. You'll also want people that know your industry very well, or you train people within the company, particularly if they're working with data that you know is private and sensitive, and you wouldn't want to expose to third parties very much. All right. Towards the finish line, I do want to leave time for questions. Is some of the resources APIX has available on big data. if you go to the APICS website, apics.org, and you click on the research link, you'll find the Big Data Folio, and you'll find the Big Data Executive Summary. These are free for members. There's good insight there. I had mentioned some of the findings from the survey at the start of this presentation. The folio has greater depth and has more conclusions and more insight than just the survey report itself has. Also, APICS has produced quite a number of articles, say, from OM Now and in APICS magazine. If you followed OM Now, perhaps you saw the one joining the Big Data Revolution from last year, October 26th, or an example in the APICS magazine, The Big Data Revolution by Richard C. Crandall, PhD in CFP, IMCR, and CSCP, most of the certs. So there's a fair amount of research available. And in conclusion, now I'd like to ask for your questions and comments, because that's what really matters, not so much old static data, but what's on your mind right now.
Thanks, Jonathan. Now it's time for Q&A, of course. Just as a reminder, you can look on the questions box on the right of your screen and click send. And we'll take a few moments and review some of your questions and give you a chance to ask them. All right, Jonathan, our first question is, how can we trust big data? Now, are there any proven validation methods?
Yes, this is a great question. Trusting data of any kind, there's really two ways, and I speak from my research background. One is the qualitative and one is the quantitative analysis. If you're getting data back from a big data system and it says, I've connected this one bit of data, or I found this particular insight and it's really valuable, the system should be able to provide statistical correlation or statistical relevance. In other words, this bit of data, this concept, this insight has a long history. It reliably shows up when X occurs. Or if not that, then it crosstabs, or it shows up in terms of segmenting for very specific customers, the particular customer that you care about. Or the big data system would say this same finding shows up 3 different ways from customers, from partners, from past history or whatnot. There should be examples, statistical relevance examples, and qualitative ways to measure as well. In other words, you could say, well, it doesn't pass the gut check. This doesn't seem right. If that's the case, if it's a big claim that big data is making, or a big data system is making, big claims need big proof. And so the system should be able to provide, here's the reasons why I'm proposing it, or here's why I think it is worth it. And that would be from the strength, the breadth and depth of where it found the data, or what it correlates to, or what it suggests in terms of priorities or relationships in decision making. I can't answer that. It's such a big question. How do you trust big data? But that's really the starting point. But it is an excellent question to ask vendors. When they say, here's our system, and it presents wonderful graphs and charts, and it makes it so easy to understand all this data. A great question to ask is, yeah, but how do I really know? How many samples does it draw from? How often is this the case? Both from a statistics perspective as well as a qualitative perspective, is it telling the same story? Do the numbers tell one story, but everything else tell a different story? So that would be my high-level answer to that.
Thanks, Jonathan. Our next question is, I've seen the terms business analytics and business intelligence come up, and I was wondering what the difference is between this and big data.
Okay, great. Business analytics, sometimes you'll just see this as BA, just the initials BA. Business analytics is a practice of iteratively methodological process of exploring data, usually with statistical analysis. What you do is you work through data, you look to see how it's connected, you see how it cross-tabulates, how it appears, how it segments with other data. And You use this in a process, and you look for advantage, you look for insight. You also look for data quality and relevancy. How important is it, or how timely is it? Examples of it would be exploring data to find patterns, relationships. This would be the classic data mining. Go through our customer database and see who we could sell more to. Another one would be to see if certain results have occurred in the past that we just might not have noticed. In other words, we think our quality is improving, but is it really improving, or is it only just an artifact of the way we measure quality? Another one might be experimenting, doing A/B testing to look at previous decisions and seeing did we get the right outcome we wanted, or we got the general outcome we wanted, but were we getting outlying results that weren't so nice that are causing problems later. Sometimes you do this with, we've just implemented a new solution, it solves a great problem, but in a few years' time it's going to create a whole new bunch of new problems. And business analytics can help suggest, are we seeing data that could suggest that's coming. Finally, forecasting, just general forecasting, predictive analytics, future results, risk management, etc. Business intelligence, or just BI, this isn't so much a practice, but rather it's an umbrella term. It's a broad category of applications and technologies for gathering, storing, and analyzing data. And it's used also for a wide variety of process and applications. It looks oftentimes, it's often used in enterprise-wide systems where you want to see big complex scenes or across many different departments, many different processes, particularly mission-critical ones. It can be enterprise-wide or local, but then sum up, the business intelligence sums up into an ever wider scene. And it would use decision support systems, statistical modeling, forecasting, data mining as well. And the real difference between the two is business analytics is a practice. It's exploration, and business intelligence really is a category. That'd be the way I'd make the distinction.
Thanks, Jonathan. Our next question is, do you have any way to tell us how big data can be helpful in certain core supply chain processes, such as material planning or distribution?
Oh, excellent. Thank you for that question. Because so many organizations are different, I'll probably have to stay at a high level. But if you're looking at planning and distribution, these are processes that are both backwards and forwards looking. In other words, if you have the responsibility for planning, say master planning, you have your master records or master scheduling and so on. That is typically based on, well, how did things go in the past? Statistically, what was the variation? What can we expect to see? And I've produced plans based on what came in the past and what we expect to happen in the future. And distribution is roughly the same thing, because the distribution will have to keep up with expected demand and supply it and keeping that in balance. Big data can be helpful in really integrating both the past and the future together. You'll have plenty of data from the past. If you're like most organizations, you'll have databases that track sales and demand and so on. And you'll have data about predictions, forecasts, how accurate they've been in the past, trends that you expect to see, insight from customers, seasonality, and so on. Big data can really sum all that up together and say, here is some insight you might have missed, or here's supporting insight for a decision, or here's information that doesn't support a decision, but it's not that big a risk because it doesn't happen all the time, or here are 3 different alternative scenarios. That's generally how it could apply, say, in a material planning or distribution process.
Thanks, Jonathan. I think we have time for just about one more question. Can you give any examples of where big data implementations can help in the automotive sector, especially possibly for predicting the future?
Oh, another great one. This is one of the real promises of big data is in forecasting and anticipation, because the human mind is great at connecting lots of different ideas together, but it's hard to get data into the human brain, and it's hard to get it out in comparison with a system like a Google indexing server, as you can imagine. So what would happen, say, in the automotive sector, where you have to, where lead times are long, where you have a new design for a car, but it'll be a number of years before it's on the showroom floor. And there's a lot of variation that could go into, say, product families. So you have lots and lots of forecasting to do, or a lot of anticipation, and there's risk to it. What big data could do is look at past practices, how successful and unsuccessful. It could look at every last bit of detail you have on competitors, on trends, and how probable those trends will be in the next 6 months, 12 months, 24 months, and so on. It can start painting a picture of, if we did this, what might happen next. In other words, if we did the following, what would the consequences be, and how would we have to live with those consequences? If we increase the size of the engine, or shrank the size of the body, or added 2 different paint colors, or what have you, that would introduce variability into the current picture. And you could ask a big data system, when we had similar variability in the past, what happened? And you can do this in an iterative process over and over again. In other words, if we say the trend is towards smaller, more efficient cars, and it will mean 100 changes, have we seen a scenario like that before? Or when we saw a similar scenario, what happened, and how did we make decisions, and what did our competitors do? All that creates just huge amounts of data, and big data is one of the few sources we have, systems we have, that claims to keep up with all that. So that's the way I'd answer that.
Thanks, Jonathan, and I'm afraid that's about all the time we have for questions today. So if we didn't get to your question, or if you have something else that you think of, please feel free to contact Jonathan at the contact information on your screen, and perhaps one day he'll use it as a future Ask APEX article. All right, so Jonathan, thank you once again for your time today. And to all our attendees, thank you for participating in this APEX Extra Live webinar. This concludes today's edition of APEX Extra Live. All content and materials included in this edition of APEX Extra Live are the property of APEX and are protected by the United States and international copyright laws. All rights are reserved.